Okay, so today's notes are a summary of everything we've learned so far in 6.1. So we've got our vocab. Power is a way of showing repeated multiplication. Our exponents is going to be how many times you're multiplying the base by itself. The base is the number that you're doing the repeated multiplication with. Scientific notation was the other thing we talked about. It's a way to show really large or really small numbers. Remember, I always have one number to the left of the decimal, and it's times 10 to some power. All right, so for our core concepts, I would recommend just writing the words part. So for our zero exponents, this is going to give you all of your rules in one spot instead of having to flip back and forth between your pages. So our zero exponents, remember anything to the zero power is 1 except for any 0 to the 0 power is undefined. So getting that part down. For your negative exponents, remember to get rid of a negative exponent. It's always the reciprocal of it. Our product of power properties, if you are multiplying powers with the same base, remember our rule is to keep the base and add the exponents. The quotient property, remember if you're dividing powers that have the same base, you keep the base and you subtract their exponents. The power of a power, if you have a power raised to another power, keep that base and then multiply the exponents. Power of a product property, if two things are being multiplied together, then each of those powers gets that exponent individually. And same thing with the quotient property. You're going to make sure that you extend that power to both of those bases in that division problem. Okay, so that's all of your rules for you in one spot so that you've got it. All right, I want you to just try some of these problems and then check back and see how you did on them. Okay, so the first one, 3 to the 0 power, that's just 1. Anything to the 0 power is 1. Negative 2 to the 0 power is also just 1. 3 to the negative fourth power is the same thing as 1 over 3 to the positive fourth power, which is just 1 over 81. Negative 4 to the negative third power is the same thing as 1 over, and then negative 4 to the positive third power, which is the same thing as a negative 1 over 64. Doesn't matter where my negative as long as my negative somewhere is in that answer. The next one, 5 to the 0 power is just 1, and then I need to move the top part, 2 to the negative third, to the denominator so that it has a positive exponent. So I have 1 over 2 to the second power, which is just 1/8. The next one, both of them have a negative exponent, so both of them are going to flip positions, so become 2 to the positive third over negative 3 to the positive second. Notice my negative 3 to the positive second power is the 2 that became positive. The negative 3 on that base stayed a negative 3. We didn't change that base at all. So this would give me a negative and then 8 over 9. Again, it doesn't matter where the negative is at. If you put it down with a 9, that's great too. All right, the next one, the denominator simplifies to a negative 1, not a positive 1. Be careful with that negative sign. It's not in parentheses. And then the negative first power would have to switch positions. So I'd actually have a negative 1 over, and then 4 to the first power, which is just 4. And number 8, the denominator would simplify to 1. The numerator would need to flip positions. So it would become 1 over 3 to the positive first power, which is just 1/3. All right, try the next section and then again check back and see how you did. So z to the 0 power is just 1. It's not z, be careful. Anything to the 0 power is just 1. A to the negative 8th power is the same thing as 1 over a to the positive 8th power. On number 11, the 6 is going to stay where it's at. A to the 0 power just becomes 1, so it cancels out. And then b moves to the denominator, so it has a positive exponent. Number 12, the 14 is going to stay where it's at. The m has a negative exponent, so it's going to move to the denominator with a positive exponent. And then n to the 0 power is just 1, so it cancels out. Number 13, the 3 is going to move to the denominator so that it has a positive exponent. The r is also going to move to the denominator so it has a positive exponent. And s to the 0 power is just 1, so it cancels out. And I can simplify that to 1 over 9, r to the third power as well. Okay, the next one, the 2 to the third power, I'm going to leave it where it's at. So I will have 2 to the third power, which is just 8. The a to the negative third power would move to the denominator with a positive. My 8 to the negative first power would move up to the top as 8 to the positive first power. The b would move up to the top with a positive exponent of 5, and the c to the 0 power is just 1, so it cancels out. I do need to simplify this a little bit more. 8 times 8 is 64, so I will have 64 b to the fifth power over a to the third power. All right, the next one, they have the same base in its division, so I keep the base and I subtract the exponent. So 3 to the second power, which is just 9. On number 16, they have the same base in its division, so I will keep that base and subtract the exponents. And then negative 2 to the second power means negative 2 times negative 2, which is a positive 4. Number 17, they have the same base and I'm multiplying them, so I will keep the base and I actually add the exponents. So I would have negative 5 to the sixth power, which is the same thing as 15,625. Okay, number 18, I have a power raised to another power, so I keep the base and I multiply the exponents. Number 19, power raised to another power, I keep the base, multiply the exponents. It's got a negative on it, so I want to flip it to the reciprocal position so that it has a positive exponent. Number 20, I'm going to simplify the numerator first. So c to the fourth times c to the third, I'll keep the base and add the exponents. And then to simplify it a little bit more, now they have the same base and it's dividing, so I will subtract the exponent. So it'll just be c to the first power or just c. Number 21, both things need to take that exponent, so I'll have a negative 4 to the fourth power, and the parentheses do make a difference on that one. So make sure you do keep that, and then I will have d to the fourth power. The parentheses make a difference because that negative 4 is a negative number. If the negative was not in the parentheses, that would end up making it a negative answer. But because you have negative 4 times negative 4 times negative 4 times negative 4, that's actually a positive answer. So it's 256 and then d to the fourth power. Number 22, I'm going to give both of them that exponent. So I have negative 3 to the negative third power and then f to the negative third power. They both have a negative exponent, so I'm going to flip them to the reciprocal spot. This would become a negative 3 to the positive third power, which is just negative 27, and then I would have f to the positive third. Again, notice there's not a lot of work on these, but this is the work that I am expecting to see on upcoming quizzes and tests. Number 23, both of them are going to get that exponent. So I have 4 to the negative third power over x to the negative third power. They both have a negative exponent, so both of them will flip positions. All right, and the last one. A rectangular prism has a length x, a width of x over 2, and a height of x over 3. Which of the expressions represent the volume of the prism? Well, to find volume, you multiply all of them together. So this means that I'm doing x times x over 2 times x over 3.